My dear student, Physics first paper, chapter number 2, Vector. My today's topic is three-dimensional vector. So my dear student, three-dimensional vector means what? A vector quantity, if it has three components. One is x component, another is y component, and the last one is z component. Then that vector is called three-dimensional vector. Suppose you are just taking any vector quantity among x, y, z axis, and that x, y, z axis contained vector is known as a three-dimensional vector. Let's draw a three-dimensional vector. Suppose this one, the Cartesian coordinate system. In this coordinate system, this axis is x-axis. This one denoted by x-axis. This one denoted by y-axis. And this one denoted by z-axis. And you see that x, y, z axis, or in this diagram, there is an origin point. This point O is known as point of origin. Suppose you just consider a point in this axis, in this plane. At this particular point, suppose this point is point P. Okay, P point is a point. P point indicate that position of a vector. That's why if you connect OP from the point of origin, this OP indicate position vector. I repeat, my dear student, this OP indicate position vector, and sometimes it is also called radius vector. So here OP is nothing but vector P, and this vector P stay among these three axes, that is x-axis, y-axis, and z-axis. That's why this OP is called a three-dimensional vector. Now I'm going to find out at first its vector presentation, and then its magnitude, and after that its direction or angle. Now to find out its three components, at first I'm going to draw a vertical line, a perpendicular line from point P to xy plane. My dear student, from point P to xy plane. Suppose you just consider that your little brother, your younger brother, just take or contain a stick, okay, from the floor. If it is stay inclinedly or at an angle, angularly, okay, then you can say that this is makes an angle with the floor, okay. This OP makes an angle with the floor, okay, and then you see that from point P, you have just draw a vertical line on the floor. My dear student, here floor is nothing but xz plane. I repeat it again, my dear student. Here floor is nothing but xz plane. Since floor is nothing but xz plane, okay, that's why what can we say? We can say that here, suppose this point is point M. This point is point M. And then we'll just join here O to M. We'll just join here O to M. Then draw two vertical lines from point M to at first x-axis and then on z-axis. Suppose the first vertical line on x-axis, this is x-axis, this is a vertical line, and then another vertical line on z-axis, so this is z-axis. My dear student, this is z-axis. Suppose we take that on x-axis, this point is point N, okay, and on z-axis, this is L, okay, this is for z-axis. Or suppose this is Q. Since this is P, suppose this is Q. So in first case, I'm going to find out, my dear student, the vector diagram, the vector presentation of this 3D vector. Okay. Suppose if I talk here vector P, okay, then obviously I must say that here vector P has three parts. One is x part, another is y part, and the last one is z part. So the first one is here, suppose px component it has y component, suppose y component, it has z component, suppose z component. Since this is a 3D vector, okay, it must contain 3 components here. Since it must contain 3 components here, we're just going to show this diagrammally or graphically or geometrically. Is it correct or wrong? Suppose by the student, here OM is a vector acting along this side. Here MP is a vector acting along this side. Okay, acting along this side. And now here this is a vector acting along this side. This is a vector acting along this side. Okay. Now, which one is the x component here, my dear student? From this diagram, which one is the x component here? X component is here, the part or the component of P that is lies on the x-axis. That lies along x-axis. Okay. You see that the part that lies along x-axis is nothing but O to N. O to N. So this O to N part, this O to N part will be called to what? The x component Px. What is the x component Px? Now you can apply here the concept of parallelogram, that is OQMN is a parallelogram. So in this parallelogram, you can say that here ON will be called to what? Will be called to here QN. Since ON will be called to QN, so it's also said that it will be called to QM. It's also said that it will be called to QM. So ON equal to Px, x component of vector will be called to QM. Just similarly, we can say that here OQ will be called to here MN. Okay, it will be called to what? This is the z component. Similarly, you can say this. And again, here MN part of the vector, MP part of the vector, this MP is acting along OY. Is acting along what? In which direction? Along here, OY direction. That's why this MP will be called to the Y component. This is PY. My dear student, this is the Y component. Okay. So this is PY. So you can say that here it has the X component, it has a Y component, there's also Z component. My dear student. Now, we're going to show this by using the concept of laws of triangle. Because you know that laws of triangle is a basic law of geometrical part of the vector. So, if I'm going to apply laws of triangle, in triangle what? In triangle here, OPM, then we can say that OP, we can say that OP will equal to what? OP will equal to here, at first OM, then MP. So first one is here OM, then here MP, my dear student, then here MP. I'm just using here the concept of laws of triangle. I'm just using here the concept of what? The concept of here laws of triangle, my dear student. Just the concept of laws of triangle. Okay. So you can say that here, sir, OP will equal to what? OP will equal to here vector P. So OP will equal to here nothing but vector P. So it's the value of OM. You see that here OM. Okay. You can convert this OM into 2 segments. First one, you can say that OM will equal to what? OQ plus QM. So you can convert this OM into 2 parts. One is OQ plus QM, my dear student. One is OQ plus QM. Okay. So we can say that it will be equal to OQ, okay, plus it will be equal to QM, okay, plus MP. Now, OQ is nothing but Z component of the vector. It's nothing but Z component of the vector. QM, by the student, QM is nothing but X component of the vector. It will be equal to X component of the vector. And the last one is here, MP is nothing but y component of the vector. Is the MP is nothing but y component of the vector. So organized, you can say that here it is Px plus it is Py plus it is Pz. Okay. So these are the three component of vector P. By the student. So these are the three component of vector P. So vector P will equal to what? Vector P will equal to here. First one is Px plus here Py plus here Pz. Okay. So this is the presentation of a 3D vector. My dear student, this is the presentation of 3D vector. Any confusion of you? Any one of you, my dear student? Any confusion? My dear student?
এখানে OZM ট্রায়াঙ্গেলে দেখাই দিলে ভালো হতো না স্যার যে OM
OZN. OZN. Okay, no problem, my dear student. O, then
OZM এ এই ট্রায়াঙ্গেলে স্যার OM ইকুয়াল টু
O. O in
এই যে স্যার O তারপর OQ প্লাস QM ইকুয়াল টু OM.
Okay, exactly. You see that here. Here OM. OM will equal to what? OM will equal to, you can say that here. This is OQ plus QM. Okay. This also, you're just following this laws of triangle here. You see that OM will equal to what? OM will equal to OQ plus QM. Okay. If you want to write down here just like this, suppose ON plus NM, this also write. Okay. If you want to write down this here, just like ON plus NM, this also write. In this case here, ON is the X component and here NM is the Y component. Is the Z component here. NM is the here, which component? It's a Z component. Okay? My dear student? Any confusion of you? Anyone? Any one of you? Any confusion? My dear student? Any one of you? Okay. Now, you see that from the concept of rectangular unit vector, you know that I hat is acting along x-axis. My dear student, I hat is acting along x-axis. Now, j hat is acting along y-axis, my dear student. And also know that k hat is acting along z-axis. So this I hat, j hat, k hat, those are called rectangular unit vector in the case of Cartesian coordinate system. Now, I'm going to find out the value of this vector. Okay, value of this vector with respect to its unit vector. So, let's see how can I convert this? How can I find out this? Px will equal to what, my dear student? Px equal to any vector equal to what? Any vector equal to its magnitude multiplied by direction or unit vector. Now, suppose Px has a magnitude is Px. And what is the unit vector? Unit vector is nothing but along x-axis, it's nothing but I hat or I cap. Very good. Now, from Py, this y component, and what is unit vector? J hat or J cap. Now, for z component, Pz, then k hat or k cap. So this is the presentation of 3D vector with unit vector. My dear student, this is also the presentation of unit vector with its component. Okay, with its unit vector. Now, we're just represent the vector in 3D vector. Okay. Now, we want to know that what would be the magnitude of a 3D vector. My dear student, we want to know that what would be the magnitude of a 3D vector. How can I find out its magnitude? So let's find out this magnitude of a 3D vector. So magnitude of 3D vector. To find out its magnitude, my dear student, I'm just going to use here laws of Pythagoras theorem. At first, you say that here PM is the vertical line on the ground, on the floor. Okay, that's why this one makes a right angle here. That's why what? This one makes a right angle here. Since this one makes a right angle here, so you can say that here OPM is a right angle triangle. My dear student, OPM is a right angle triangle. Okay, so since triangle OPM is a right angle triangle, you can apply here laws of Pythagoras. That is, hypotenuse square OP square will equal to what? OP square will equal to here OM square plus MP square. My dear student, OP square will equal to what? OM square plus MP square. Okay. Now, I'm just going to break down the value of OM. So OP square is nothing but vector P square. So OM. You see that in triangle OQM. My dear student, in triangle OQM is also a right angle triangle. Since this is also a right angle triangle, so by using Pythagoras theorem, you can also find out the value of here its true component from triangle OQM. That is, in the place of OM, you can write down here OQ plus QM. So it will equal to what? It will equal to here OQ square plus it is QM square. QM square plus this is MP square. Now, my dear student, OQ lies along z-axis. That's why OQ will equal to px square. Then QM lies along x-axis. My dear student, QM lies along x-axis. That's why this is py square. Yes.
Sir, OM square ke bhangle OQ plus QM whole square hobe na?
OQ plus QM whole square ke hobe? You know that hypotenuse square equal to what? Hypotenuse square equal to base square plus normal square. My dear student, this is the concept of Pythagoras theorem. Okay? Is it clear to you?
Yes, sir.
Okay, very good. Now, MP, QM is nothing but X component. So OQ is the Z component, my dear student, Z component. QM is nothing but here X component, and MP is nothing but Y component. So PY square. You need to find out the magnitude of P. So the magnitude of P will equal to what? Magnitude of P will equal to Px square in organized way plus it is Py square plus it is Pz square, my dear student. So this is the magnitude of a 3D vector.
right angle triangle বোঝাচ্ছে না
My dear student, so this is the magnitude of a 3D vector. Okay, now up to this point, anyone, my dear student, any confusion here? Up to this point, any confusion here?
Yes, sir, I have a confusion.
Yes.
স্যার এখানে তো স্যার পিএম তো স্যার সবচেয়ে বড় সাইজ, সে কারণে স্যার এটা হাইপোটেনাস হওয়ার কথা না স্যার, ওপি কেন হাইপোটেনাস হবে?
Okay, very good, very good. You see that, my dear student, this is a 3D diagram. Okay, so it's a very tough to draw a 3D diagram in 2D space. You know that this board is a 2D space. Okay, this board is a 2D space. Okay, so you're just going to draw a 3D diagram on this 2D space. That's why it seems to you that it looks that PM is more than or PM is greater than OP, but it's not. Obviously, PM is not more than OP. Okay, you just imagine that a stick, you just put a stick on your floor, okay, inclinedly. Then you're just going to draw a vertical line from the topmost point of the stick to the floor, topmost point of the stick to the bottom surface of the floor. Then, does this PM is more than that of the length of the stick? No. And why I'm just using here OP is hypotenuse. You see this, my dear student? OP is a vector. And from this point P, I'm just going to draw a vertical line on the floor. Since I'm just going to draw a vertical line on the floor, that's why PM is the vertical line on the floor. What does it mean? On the floor surface, PM makes a right angle. That is 90 degrees. Now, your concept is clear?
Yes, sir.
Okay, very good. Any more confusion, my dear student? Anyone? Anyone, my dear student? Any confusion here?
No, sir.
Okay.
Sir, I
Yes.
have a confusion.
Yes.
Sir,
Yes.
is this vector is called as radius vector?
OP is a position vector because this OP indicates the position of point P, and this position vector sometimes known as radius vector. That's why this OP is also known as a radius vector. Okay. Okay, my dear student. Is it clear to you?
Yes, sir.
Yes, sir.
Okay, now my dear student, I'm going to find out unit vector of a 3D vector. And let's see how can I find out the unit vector. Okay, so let's see how can I find out the unit vector of a 3D vector. Let's see this. You see that here a 3D vector P will equal to what? Will equal to here Px, then I hat plus it is Py, then J hat plus it is Pz, then K hat. And after that, you also see that the magnitude of vector P will equal to what? Will equal to root over, the first one is Px square, the second one is Py square, and the third one is here Pz square. This is the magnitude. Okay, my dear student. So first one is the 3D vector, and the second one is the magnitude. Now, I want to find out the unit vector of P. So, unit vector of P will equal to what? Will equal to vector divided by its magnitude. My dear student, vector divided by its magnitude. Now, vector P will equal to what? P will equal to, you see that here, this is Px I hat plus this is Py j hat or j cap plus this is what? Pz k hat or k cap. And 1 divided by the magnitude of vector P. You see that the magnitude of vector P will equal to root over. This is Px square plus this is Py square plus this is Pz square. My dear student, this is Pz square. So, Px divided by root over Px square plus Py square plus Pz square into I hat. Plus with that, Py divided by root over, this is Px square plus this is Py square plus Pz square into j hat. Okay, plus Pz divided by root over, first one is here Px square plus Py square plus Pz square multiplied by k hat. My dear students, so this is the unit vector of a 3D vector. This is the unit vector of a 3D vector, okay? My dear student, this is the unit vector of a 3D vector. Anyone? Any confusion here? the unit vector of a 3D vector, my dear student? And confusion here?
No, sir.
Okay, so this is the theoretical part, and on the basis of this theoretical part, I'm just going to solve some mathematical problem. Okay, suppose vector P is a 3D vector, 2i hat plus 4j hat minus k hat. This is a 3D vector. The question is here, the first question is here, find out magnitude of P. Question number B, find out unit vector of P. Okay, so this is the question, my dear student. So this is the question. So first of all, I want to find out the magnitude of vector P. You know that the magnitude of a 3D vector P will equal to what? Will equal to root over, at first it is px square plus it is py square plus it is pz square. So the first one is it is px square plus py square plus it is pz square. So px will equal to what, my dear student? The coefficient of I hat is known as px. You see that this 2 is the px. The coefficient or multiply of j hat, this is the y component. So this is py. And the coefficient of k hat is the z component. So this is pz, my dear student. So you can say that here px equal to 2 square plus py will equal to 4 square. And pz will equal to what? Pz will equal to minus 1 whole square. Okay? Pz will equal to what? This will equal to minus 1 whole square. Now find out the magnitude of this 3D vector. It will equal to,
So 4.58.
if you make it a whole number, that is 16 plus 4, 20, 21. Okay? It will equal to 21 unit. Okay, my dear student. So what's the magnitude of this vector P? It will equal to root over 21 units. Okay. Now, my dear student, question number B. I have to find out the unit vector of vector P. I repeat, my dear student, I have to find out the unit vector of vector P. So the unit vector of vector P, eta hat or eta cap will equal to, this is 2 vector P divided by its magnitude. Now, what's the vector P, my dear student? Vector P equal to 2i hat plus 4j hat minus k hat divided by P will equal to root over 21. Now, eta hat will equal to 2 divided by root over 21 I hat plus 4 divided by root over 21 j hat plus, no, it's minus, so minus 1 divided by root over 21, this is k hat. Okay, this what? This is k hat. Okay, so we can say that here eta hat or eta cap equal to 2 by root over 21 I hat plus 4 by root over 21 j hat minus 1 by root over 21, this is k hat. So, my dear student, this is eta hat, unit vector of this vector P. Anyone, my dear student, any confusion here? Any one of you? My dear student, any confusion?
No, sir.
No, sir.
Okay.